So, welcome all. Today we are going to say something about first and follow in compilers. Basically, these are two important functions which will help us in top-down and bottom-up parsing techniques. So, given a grammar, actually we try to find out first of some symbol, right? So, first and follow of these symbols. So, for example, if you want to find first of a given symbol, say let me write first of alpha. So you will have to follow some rules, very simple 3 rules, and you will try to see and understand that it will be very easy to find this first and follow of a given symbol. Now it will first rule will according to this first rule, it will say that if this alpha, if the given alpha is actually a terminal, we first of all let me tell you about terminal and non-terminal. That actually in the grammars usually it is something like E gives E plus E, and then this or it may give int, and suppose this int gives so this int gives something called your 1, 2, 3 or so on, right? So here these values are terminal, and the other values maybe E or int, they are let me write it that these are terminal and these are non-terminal. Okay. So the first rule says if the symbol under consideration alpha is a terminal, what we will do. So if alpha is terminal, if alpha is terminal, in that case first of alpha will be the terminal itself. Okay. Now second rule says, so the second rule says if alpha is non-terminal, what to do, right? So suppose alpha is non-terminal. Non-terminal means any capital letter kind of things. Non-terminal. Okay. So in this case what will happen, there are two things. First is, suppose this our variable alpha, this non-terminal, if at all it is non-terminal, then it will derive something. Non-terminal is, if at all, then this non-terminal will derive something, right? It may derive some non-terminal, it may derive some non-terminal, or it may derive some terminal. So if alpha is deriving something, and one thing is epsilon, right? So if alpha is deriving epsilon, in that case what will happen, first of alpha will be first of epsilon, right, which is epsilon itself. Why? We have already seen first of a terminal is always a terminal only. So first of this non-terminal is something first of something on the right hand side, right? So first of alpha is first of something on the right hand side, and it is epsilon only. So first of epsilon is epsilon. Now if we are thinking about second, okay, one more thing can be, if at all this alpha derives something, suppose it derives x1, x2, x3, okay. At the same time, we are if at all we will try to find the first of alpha, it will be first of x1, x2, x3, isn't it? Now let me consider one more thing with this, that this first variable x1 derives epsilon, okay. So what will happen, we can cover two rules together. So what will happen then, if we try to find the first of alpha, it will be first of x1, x2, x3, right? So this is actually first of x1, right? First of x1, x2, x3 will be x1, all of them are if this thing non-terminal, so it will be first of x1. If at all x1 would not have any epsilon, in that case the first of x1 is enough, right? Let me write it, first of x1. But one more thing is this thing, x1 has epsilon also. In that case, what will happen? I should say union. First of x1 union first of x2, x3. So this is something about this first function. Suppose, let us have an example here. We had this example, right? Okay, let it be another example, let us take. So if we are considering some example of a grammar, it may be, suppose S gives I, E, T, S, S dash and A also. This S dash gives E, S, as well as it also gives epsilon, and this E gives B, okay. So what will happen if we are thinking about first of, suppose S, first of S will be first of this part, first of this part is I, so I is the answer. If I ask you first of A, first of A is A itself, okay. If I ask you first of S dash, so first of S dash is first of this part, suppose E. If here suppose for E we have AB, and this A gives A or epsilon, okay. In that case, if we are trying to find first of, suppose E, first of E will be first of this part AB. This will be first of A only. It will be first of A union first of B also. Why? Because A also derives epsilon, right? So first of remaining part. First of A will give you A as well as epsilon, right? Union first of this part. This is B, right? So this is how you try to find this first function. Now we will try to say something. This is so if at all we want to see this thing follow. So follow, you will try to find follow of some non-terminal, right? But now you have to see whether this symbol is where this symbol is placed in your example. So let us consider the rules. First rule says, if at all this symbol A is a start symbol, if it is a start symbol, in that case what will happen? In that case, follow of this particular A is a symbol dollar. Okay. Now the second rule, it says if at all it is not a start symbol, in that case it is somewhere, right? So suppose there is a production, I should say alpha derives A beta C. Okay. So now if you try to find this follow of A, what will happen? It will be follow of A is first of the remaining part. Okay. Beta C. Okay. Now the third rule. Third rule will tell you that if at all we have something like alpha derives suppose B and A, when this A is in last, one more thing, suppose alpha derives B, A, C and C derives epsilon, then also A becomes in last. So if at all such conditions arises where A is in last, in that case you have to find the follow, then follow of A will be follow of this symbol alpha. Okay, so these are the three simple rules for your follow function. If at all this thing, if alpha is a start symbol, then follow of this symbol will be dollar, and if this is something like this where alpha derives A beta C, means A is somewhere here in the right hand side where you can find something after A. In that case the follow of A will be something which is first of this part. Okay, and if at all it is in last, in that case it is follow of the non-terminal symbol on the left side. Okay, this is the simple thing that we have to learn here. If at all our previous example is concerned, we can find some of the things from there. Suppose the S derives, it was I E T S S dash, it also gives A, then it was S dash gives E S or epsilon, other thing was E which gives B. I also kept something A here which A gives A as well as epsilon. Okay, so here if you try to find something related to follow, so suppose follow of which follow of E, follow of E is, so now for follow of E we are not going to see this place. Okay? For finding first of E we saw this part. Now for follow of E we try to see where this E appeared on the right hand side. It is here, right? So after E, whatever the part is here, first of this part. Okay, first of T S S dash. So T is a terminal, so this is T. Now if you want to find the follow of something like A, so you will see where the A appeared on the right hand side. So you will find the first of this part, it will be B. If you try to find the follow of S, it will be dollar. Along with this, in this case or this example, follow of S is since it is a start symbol, it is dollar, it is true, as well as it is also appearing on the right hand side here, right? So it is first of S dash. I should write union first of S dash. Okay, not only that, S is also appearing here, right? So it is also in follow of S dash. It is the last symbol here, so follow of S dash, it is also union follow of S dash. So it is dollar, as well as first of S dash is, first of S dash you can see it is E, right? Follow of S dash is, S dash appears here, follow it, since it is the last symbol, so it is follow of S. Okay, so what happened? So in this case it will be dollar and E only. So in this way we try to find follow first and follow for grammar, sorry, for a symbol in a grammar. So this is a very simple thing, and in next video we will try to understand what is left recursion and left factoring and how these two are removed. We will see this because here, since we are going to see recursive descent parser or others, so with these recursive descent parser needs this grammar to be free from left recursion and left factoring. So before seeing this recursive descent parser, we will try to see what are these left recursion and left factoring and how they are removed, right? So we'll see this in next video. Till then, thank you.